All right, let's dive into a topic that honestly trips up a lot of people in data science: standardization versus normalization. They sound similar, but choosing the right one is absolutely crucial for building a good model. Today, we're going to make that choice crystal clear. So let's start with a question. Why is it that huge numbers can so easily fool our really smart algorithms? I mean, it seems kind of strange, right? Well, it all comes down to a problem of scale, and it's the exact reason we need techniques like standardization and normalization in the first place.
Just imagine this. Your model is looking at two features: age, which might go from, say, 25 to 60, and then salary, which could be anywhere from 30 grand to $500,000. Without us stepping in, a lot of algorithms will just look at those raw numbers and think, wow, salary must be way more important, just because the numbers are bigger. And that's a bias we have to correct. So, how do we stop our models from getting distracted by these big numbers? Well, we bring in the two main contenders in the world of data scaling. Let's meet them.
Now, before we get into what makes them different, you gotta know that they share the exact same mission. The whole point of both of these techniques is to take all of our features, no matter what their original scale was, and put them all on a level playing field. It's all about making a fair comparison.
First up in the ring, we have normalization. I like to call this one the great rescaler. Why? Because its whole strategy is to take every single data point and shrink it down to fit inside a nice, predictable little box. So the more technical term for this is min-max scaling, and it does exactly what it sounds like. It's a technique that rescales all of your numbers so that every single value gets transformed into a new value somewhere between 0 and 1. Your absolute smallest value becomes a 0, your absolute biggest becomes a 1, and everything else just falls in line somewhere in between.
So how does it actually do that? Well, it's a pretty simple little formula. For any given data point, you first subtract the minimum value of the whole data set from it. Then, you just divide that number by the range of the data, which is just the max value minus the min value. And voila, the result will always be a number between 0 and 1.
But, and this is a big but, normalization has an Achilles heel, because the whole calculation depends on finding that absolute minimum and absolute maximum value. It is super sensitive to outliers, those one-off extreme data points that just don't fit in. In a perfect world, with perfectly clean data, normalization is beautiful. You can see here, our data points are spread out nicely across that 0 to 1 range. Everything looks great. This is the ideal situation. But now, watch what happens when we throw in just one huge outlier. Suddenly, that outlier becomes the new maximum, so it gets the value of 1. And the problem? Look at all our other data points. They all get squished into this tiny, tiny little corner down near 0. All the useful information and the differences between them, pretty much gone. Okay, so that's the story with normalization. Now let's bring in our second contender, standardization. If normalization is the great rescaler, then you can think of standardization as the center shifter. It has a completely different game plan.
Standardization, which you'll also hear called z-score normalization, couldn't care less about squeezing data between 0 and 1. Nope. Its goal is to transform the data so that its average, its mean, is exactly 0, and its standard deviation is exactly 1. And the math for this is also really straightforward. You just take any value, subtract the average of the whole data set, and then divide that result by the standard deviation. What pops out is something called a z-score. So what on earth is a z-score? It's actually a super useful concept. It literally just tells you how many standard deviations away from the average a data point is. So if you have a positive z-score, your data point is above average. A negative score? It's below average. Simple as that. Okay, so we've met our two fighters, we know their game plans. Now it is time for the main event, the head-to-head showdown. Let's put them side by side and really see what they're made of. All right, let's really break this down. First, their goals are totally different. Normalization wants to lock everything into that fixed 0 to 1 range. Standardization just wants to recenter everything at a mean of 0. That means the final range of your data is always bounded with normalization, but with standardization, it's not. Now here is the most important part, outliers. Normalization is super sensitive to them because one extreme value completely changes the min or max. Standardization, though, it's way less sensitive because it uses the mean and standard deviation, which are much more robust and aren't thrown off as easily by a few outliers. And finally, it's good to remember that neither of these is going to change the basic shape or distribution of your data. They just shift it around. So after all that, how in the world do you actually make the right choice? Who's the winner here? This really is the million-dollar question, isn't it? You've got your data set sitting right in front of you. You know the pros and cons. What do you do? Which one do you pick?
Okay, here's your cheat sheet. You're probably going to want to use normalization when your data doesn't really follow a nice bell curve. Or, and this is a big one, if you're using an algorithm like some neural networks that specifically needs its inputs to be in that 0 to 1 range. On the other hand, standardization is usually your go-to when your data does look like a normal distribution and, most importantly, when you suspect you might have outliers and you need your model to be tough against them.
So what's the real takeaway here? It's that there is no single champion. There is no best technique. The right choice always, always depends on your specific data and what you are trying to accomplish with your model.
Look, getting your data skilled correctly is a massive first step. But it's really just the beginning of the journey. It's the key that lets you unlock everything else. So I'll leave you with this to think about. Now that your data's finally on a level playing field, what other hidden stories is it ready to tell you?